Welcome to our journey through the cosmos. Today, we delve into the fascinating story of Jupiter, the giant of our solar system. How did this massive planet come to be? To answer this, we must travel back in time, over 4.5 billion years ago, to the very beginnings of our solar system. In the beginning, our solar system was nothing more than a vast cloud of gas and dust, known as a solar nebula. This nebula was composed primarily of hydrogen and helium, the most abundant elements in the universe, along with traces of heavier elements formed in previous generations of stars' gravity. The force that holds the universe together began to work its magic. As the solar nebula collapsed under its own gravity, it began to spin, forming a flat, rotating disk. At the center of this disk, where the concentration of mass was greatest, the sun began to take shape. Further out in the disk, small particles of dust and ice started to stick together, forming clumps. These clumps collided and merged to form larger bodies called planetesimals. Over time, these planetesimals grew larger through a process known as accretion. Among these forming planetesimals, one in particular began to stand out. Located in the outer regions of the solar system, this growing body was destined to become Jupiter. But how did it manage to become the largest planet in our solar system? Scientists believe that Jupiter formed through a process called core accretion. In this model, a solid core of rock and ice, about 10 to 20 times the mass of Earth, formed first. This core had enough gravity to attract a vast envelope of gas from the surrounding nebula. As the core grew, its gravitational pull became stronger, allowing it to gather more and more gas. This gas, primarily hydrogen and helium, accumulated rapidly, enveloping the core and forming the massive gas giant we know today. The composition of Jupiter's atmosphere gives us clues about its formation. The planet is made up mostly of hydrogen and helium, similar to the Sun, but it also contains traces of other elements like methane, ammonia, and water vapor. These elements were likely captured from the solar nebula during Jupiter's formation. Jupiter's formation didn't just give rise to the planet itself. The process also led to the creation of a complex system of moons. As Jupiter grew, its gravity began to dominate the surrounding region, capturing planetesimals and smaller bodies. Some of these became the Galilean moons, Io, Europa, Ganymede, and Callisto, while others became part of the planet's extensive satellite system. But the story of Jupiter's formation doesn't end there. Recent research suggests that Jupiter may have migrated from its original position. In the early solar system, gravitational interactions with other forming planets and planetesimals could have caused Jupiter to move inward or outward before settling into its current orbit. Jupiter's formation didn't just give rise to the planet itself. Today, Jupiter continues to play a crucial role in our solar system. Its immense gravity acts as a shield, protecting Earth and the other inner planets from potential asteroid and comet impacts. At the same time, it serves as a dynamic laboratory, helping scientists understand the processes that shaped our solar system and the formation of planetary systems around other stars. Jupiter's story is a testament to the intricate and awe-inspiring processes that govern the universe. From a cloud of gas and dust to a magnificent gas giant, the journey of Jupiter's formation is a reminder of the dynamic and ever-evolving nature of our cosmos. Thank you for joining us on this exploration of Jupiter's origins. Stay curious and keep looking up at the stars.